So as Peter said, I'm the EPO, or Education and Public Outreach Lead. My name is Alexa, and I'm just going to briefly introduce Jenn, who we have the honor of having today as our Smart Talk speaker. She'll be giving a talk on space science in the commercial sector, from discovering to pioneering. And Jenn, or Dr. Jennifer Gannon, received her PhD in physics from the University of Colorado at Boulder. She spent 10 years as a federal scientist, first for the NOAA Space Weather Prediction Center, and then for the USGS Geomagnetism Program, before joining the commercial sector. She's now the Vice President of the R&D Division of Computational Physics Incorporated, serves on the editorial board of AGU's Space Weather Journal, and is a member of the Federal Space Weather Advisory Group. So we're very excited to hear from her, and I'll let her take the floor.
Thank you so much for the invitation. It's great to virtually be with you guys at UCLA. Should I share my screen here? Is that probably the best way to do this? Let me see if I can get. Can you guys see my slides?
Yes, we can see it.
I know this is supposed to be fairly informal, so feel free to interrupt me if you've got questions. One of what I really want to talk about is being a scientist in the commercial sector, and this is one of those things that confuses so many people about my job when they meet me, is that I'm doing research science, but I'm working for a company, and it's often met with a bit of initially skepticism, and then confusion. How can you do research and not be at a university or a government lab? I didn't actually quite start out this way. I started out as a government research scientist. I started down that more traditional path. And along the way, I found out there were two things that I really enjoyed. And the first is that I love space, as of course, everybody loves space. As I'm sure I don't have to make the argument to any of the folks in this seminar, these folks here. Space is cool. I love space, and I love space science, and I particularly love space weather. But what I really love is data, lots of data. And the power of data to inform and protect and really do research and discovery with. So like I said, I started out working for the federal government, which was wonderful. They have a great mission. It's a big mission. I still get to participate in that in certain ways, but for the past almost 8 years now, I've been doing space science in the commercial sector because everybody needs data. The government needs data. There's been some changes recently that allows commercial entities to work more closely with the government. The Pro-SWIFT Act passed Congress, very much to our excitement, which includes a lot of different things like how NASA and NOAA interact. It was one of those really, really weird government acts that was completely bipartisan and completely bicameral, so it just had support across the board, and included some very specific things for the commercial sector, including the mandate for the government to get data from the private sector. So the government needs data. I love data. I'm working in the private sector. It works out great. But in case you haven't heard, and I know everybody has, there is a commercial geospace explosion going on. And I had to look this up, according to the UN Office for Outer Space Affairs, which has an acronym I am not going to attempt to pronounce. There's over 10,000 individual satellites in space right now. So this is a really, we're exponentially increasing the number of satellites that are in space. So in more than 60 years, a little more than 60 years, we've gone from having one satellite, the moon, our original satellite, having over 10,000, and this is not counting space debris. This is not counting all of the non-functioning satellites that are up there for various that have gone out of service or gone into the end of mission. So it's a new era of really pioneering in the commercial sector for space science, and it's being done by some really smart companies. And it's also bringing with it a host of new problems, and new things to solve, new issues to get past. I know everybody's heard of Starlink and SpaceX's endeavor to launch all of these satellites, which is driving so much of this new geospace revolution. And they're gonna cover the sky with satellites, and that's wonderful from one perspective. You get to bring internet to places that don't have internet, but it also causes issues for other folks. If you look at the plot on the right side, this is an imager from our all-sky imager at Arecibo that the CPI runs, and usually it's looking at atmospheric phenomenon or auroral phenomenon, and instead today it's looking at Starlink. And of course, I just happened to capture the Starlink chain as it passed over, as it was launched. And I looked at this and I was like, cool, satellites. And my colleague, our chief space scientist, was like, he's got an astronomy background, and he's more on the side of what are these satellites doing, blocking my view of the stars and the atmosphere. So as this explosion in revolution and pioneering in geospace and commercial geospace occurs, there's really a lot of stuff that we've got to work out, and a lot that data and science can contribute to. And the reason all of this is happening is big companies are going to space. Companies in general are going to space, and they're all going to need products that describe the space environment and space weather, what's going to happen to their satellites when they launch them, so that disasters and issues don't occur. I think many people have probably heard of the Starlink loss. A few months ago, there was a launch of one of the Starlink chains where they lost 41 of the satellites during a very small geomagnetic storm. So a very small interaction between the sun and the earth. It was a G1 class, one of the smaller events, and it had a huge impact on Starlink. And it's space weather information and data that can help mitigate and prepare for that and avoid it. There's other big companies that are doing things both on their own, as downward looking, like Maxar or some of the other remote sensing kind of companies, and there's large primes that are doing collaborations with NASA and other entities. So it's just becoming more of a cross-sector endeavor. Universities, government, and the commercial sector. And small companies like the one I'm working for are also going to space, and in a bit of a different way. But in a way, there's this whole commercial ecosystem forming around this geospace explosion. Most of these small companies can't launch satellites, not like NASA or not like the big companies, but some are involved in CubeSats, some are involved in doing the science, some are involved in doing mission ops or participating in these big missions. So there is an explosion in science and product development, not just at the big guys, but also the little companies like CPI, like the one I work for. So, a lot of the things that we do at some of these smaller companies are going back to that first love of mine, which is producing lots and lots of data. So small companies are instrument and data providers. Like I said, participating in CubeSats and in data buys to the government, and in building sensors and deploying instrumentation, and in working across the geospace spectrum from research to operations. So, and this is like I said, almost more surprising to folks. We also do quite a bit of science. We're builders of real-time models. We build operational models of the sun and solar wind and space. CPI in particular works a lot in upper atmospheric and magnetospheric and ground-based observational work. We work on NASA grants, we work on NSF, DOE, and other kinds of grant-funded science. And often a lot of this is also funded through internal IR&D. So governments or companies can fund themselves in sort of a different way to do science that has a different application. And these are just, some of the examples of how we do science, but we do science in the commercial sector. And it's just another way, it's another path other than academia or the federal research labs that has, pluses and minuses. So as part of the commercial sector, I get to participate in the science community. Like I said, I'm part of the AGU Space Weather Journal. I get to work with government science. I get to be part of advisory groups and work with some of the larger projects or go after government grants. We get to do NSF and NASA funded science, like our MagStar magnetometer array, which I'll talk a little bit more about too. It's very complementary, I think, to the SMART array and the work that Peter and you guys have done. And we get to work with end users a lot. And this is getting back again to my kind of love of data and making things practical, using the data to make things practical. We get to work with power utilities and other commercial entities needing space weather data. So the MagStar project was funded by NSF as well. It's got a 10-year history of development, mostly through NSF funds. The most recent began right at the beginning of the pandemic in 2020, which was a great time to put out operational sensors. Not so much. It was pretty hard to travel and deploy during that time. But the goal was to put them in some observational holes and really support real-time operational data. So focusing on the infrastructure and some of the stuff that we were already doing at CPI, some of the cybersecurity and data management infrastructure. And we've been able to support data delivery to NOAA sweep team, researchers, and end users, which is, the thing that drives space weather is how does that sun-Earth interaction affect the end user? That's by some people's definition, the definition of space weather, the impact on end users. We tend to call those customers instead. Sometimes they work with us on government grants as well. But that's one of my favorite parts of working in the commercial sector is really being able to interact in a different way with end users, because they're quite often in the commercial sector as well. And one of the primary groups that we get to work with, and a group that's affected by space weather, similarly to all these satellite constellations that are going up, is power utilities. And it turns out they have a lot of data too. They have quite a bit of data. What I'm showing here is sort of a synthetic version of a power grid. You can't show a lot of power grid information because it's pretty sensitive. But we work very closely with power utilities, both on our NSF grants and in our commercial projects to share data, to understand the impacts of space weather on their systems. They share data with us, so we understand if our models are working correctly, or if our data is useful to them or not, or how we can improve things. And it's a really nice feedback loop between end users and developing the science. And the power system, the power grid's very fun to work with. It's a massively complicated and really truly impressive system. I had no idea when I started working on power grid impacts 15, 20 years ago, much more than you turn the lights on, you turn the switch on and your lights come on. But this is the power system. Wow, it's a massive machine, in huge parts has to oscillate, in time together, and the generation of power and the loss of power. It's a very delicately balanced thing. It's really very impressive to me how well the power system works, and how much it can be affected by things like space weather. So power utilities are very interested in mitigating for these things and finding data sources wherever they can. And the reason they like to do that is that their equipment's expensive, so most of space weather affects the extra high voltage transformers, the biggest transformers that help move power across the US. These are extremely expensive things. I wouldn't even hazard a guess how much these things cost. And they don't want this to turn into this. And during space weather, you can have effects which can literally burn out an EHV transformer. The first one was not actually an EHV transformer. It was something I shamelessly got off of Adobe stock images. This one's an actual image of a transformer that everybody uses, attribution unknown at this point, unless Peter wants to correct me, then maybe knows where this picture came from, but it's an actual image of a transformer that was burned out during a space weather, a geomagnetic storm event. So they want to protect their equipment, and they've got a motivation to protect their equipment and work with data providers and scientists in better understanding how to do this. So, you know, in addition to working with government and academia, as a scientist in the commercial sector, my work with end users has probably been some of my most enjoyable. We've been very lucky to have a lot of commercial partners, like I said, that are often commercial entities themselves. And that's what I really enjoy most about all of it is doing the space science and making this data practical and useful to folks like the energy sector, and hopefully as this geospace revolution continues and these geospace pioneers get out there and these commercial companies are deploying more satellites, there'll be even more opportunity to do science and provide data to all of these sectors. So thank you very much for your attention. Thanks.
Yeah, thank you. I'll say, unless Peter has some closing words, but if anyone has questions at this time, they can direct them to Jenn, and the floor is open for that.
Yeah, it was a wonderful presentation.
Thank you.
Since you're kind of in like these companies that are in like the cutting edge of like collecting these like data and like developing like space weather research, like what do you think will be like the greatest change we'll see in our lifetimes due to this projects like these?
Oh, you're going to start with the small questions. I think the changes, I don't know. I think there's some big battles ahead, and you know some of the fights over like the Starlink chain or the disagreements. You know, how do you balance the needs of providing internet to corners of the world that don't have it with the needs of the astronomers who want to do science? And you know, and you think of that as it's a practical societal implication on both sides. You know, neither side's wrong, but as you get more and more people really engaging in geospace, it gets more crowded, and the more crowded it is, you know, the more conflict and the more competing needs. You know, we got to have both, and we got to find ways to balance both, and that's a really hard problem. So I think the way that evolves is going to be interesting to watch.
Thank you. Yeah.
Hey there, I also have a question if there's time for that. First, I just wanted to say it looks like you're doing some interesting stuff. So thanks for giving the talk. It was pretty interesting to hear about. But I guess my question isn't quite as thought-provoking. I was just curious, what would you say to someone looking to get into this type of field? You know, do you want to be like a highly skilled generalist, or do we want, you know, PhD with, you know, very specialized knowledge? You know, what type of qualifications would make someone a good fit
to go to the commercial sector?
Right. Yeah.
Yeah, that's a great question. And I think it depends on what kind of work in the commercial sector you want to do. I know a lot of aerospace grads in particular end up going to companies like SpaceX or Amazon to help out with the Kuiper satellite array that they're launching. And they're trying to go in with the science mindset to help them balance these big problems and these big arguments. So I think, you know, being a specialist in some of the space debris or the space situational awareness can be a really good path if that's of interest. For small businesses, if you like the small business aspect a little bit more, and in small business, there's a lot of flexibility, in this small business can be a lot of fun. You have to wear multiple hats, but you get to wear multiple hats, which is kind of fun. And so in small business, being a generalist is really good. Technical skills, being able to program, being able to understand modern infrastructure, which I'm sure you guys are all doing, it is another very good skill. So it kind of depends on where you want to end up. Large primes, I'd say again, maybe a specialist, being an expert in a specific domain, so just like you'd specialize in a topic in academia or government. Some of the larger companies are really looking for those topical experts. A great question.
Very insightful answer. Thank you.
Thank you for giving this talk. I was very inspired by it. As a current CSE student, what would be like some good examples of classes to take to learn more about like this sector and going into it? Because the way you described it is like it's like something very new, right? Like we're going into like this okay, well, yeah. So what kind of classes would you recommend taking to learn more, basically?
And I might defer to Peter on that one, but I would say, a lot of the stuff, you got to have a combination of physics and the space science, so you understand the application. Some of the newer stuff too is also in the aerospace departments, and I don't know how UCLA really divides up some of those classes. I went to the University of Colorado, where a lot of the space weather, space science was done in the aerospace department, although I was in physics, so I was kind of a weirdo. Peter, do you have any thoughts on that?
I always think myself as a student as well. So this is also the question I look for answers. So, but I think it's great to know what you think. Well, in fact, Roland and Brian are asking some of the question. I asked all the our distinguished speakers that what are the smart things to do for us at this stage at UCLA, for example, especially for undergraduate students. So perhaps they have different choices they can take when they graduate. So in fact, not answering any question now, but I just want to throw out another question for you, because you're in the commercial sectors. And what do you think about the undergraduate students when they are about to graduate? What would be smart things to do when they choose their path moving forward to do well in the commercial sectors that you're familiar with?
I think these questions are kind of related. As you were talking, I had a couple more thoughts about areas that can be very important for both commercial sector, but I think really also for academic and federal science. But if you're talking about getting into the geospace revolution, there's a lot in systems thinking. So systems engineering is a lot of times we like to focus on the science, but forget how to integrate all of the pieces together. Programming, learning modern programming techniques and languages is never a bad thing. Particularly when you're trying to work with some of the bigger commercial customers, or even building something just operational. Learning Julia, learning how to build infrastructure, learning how to do some of these engineering applications. So this is maybe even making me rethink my previous answer, that generalist approach can really help a lot of paths into the commercial sector. That particularly if you want to take science and take the science you've learned at an undergraduate or graduate level and apply it in the commercial sector, having that systems and that engineering, a little bit of systems and engineering and programming knowledge is very helpful.
Those are all really good questions. I had a question myself, if no one else has any right now. I was just wondering, in terms of the commercial sector, and especially when you compare it to academia, which I think has this kind of notion of being very worldly, so all these academic institutions across the globe, sharing science and just working together in different ways. Does the commercial sector seem pretty self-contained in a sense? So obviously you're going across the nation, but how much interaction is there, I guess, abroad, especially in terms of you're talking about like electrical systems and all that? I'd be interested to know.
Yeah, so you're asking how much international collaboration we really do? Yeah, this is the commercial sector compared to federal and academic, you can do a lot of the same things, but the rules are kind of different. And the motivations are kind of different. So collaborations in some ways are easier. I would say I probably find it easier to work with my power engineering partners because they're very comfortable speaking commercial sector to commercial sector, more so than maybe some of my federal colleagues. For international stuff on the power side, there's a lot of international collaboration because space weather and space science it's a global thing. It's a global phenomenon, very, very local impacts. So you may be studying local impacts, but the collaborations are still global. I would say that I probably do less international collaboration on the research side now, which is a little strange now that I think about it. I think the barriers are probably more on the commercial sector, the companies not wanting to work together, being competitive. I've seen less of that. And maybe it's just my fault for not reaching out to my international collaborators. But I'd say, in a lot of ways, the collaborations are similar, but you got the rules are just a little bit different. The motivations are different. Sorry, that was kind of a vague circular answer, but that's a great question.
No, that makes sense. Thank you. It's obviously kind of a complex thing to address. So awesome. Any more questions from the general audience?
I guess I had one question, which is, so just as an industry specific thing, I've heard from a lot of people that like the aerospace industry has I don't want to say worse, but like a little bit more of like a worse work-life balance, I guess, than a lot of software engineering companies.
Yeah.
But as someone who's like really interested in going into aerospace engineering, I'm like curious at your perspective on that, or like if you think like different companies definitely matter. But I was just wondering, like, kind of an open-ended question.
It is so important, work-life balance is so important. I usually get this question in comparison between commercial and federal. There's this impression that maybe we work more hours in the commercial sector than we do in federal research. I think a lot of that depends on the individual companies, and the cultures of the individual companies. I would guess there are lots of academics that work, I bet Peter works a lot of hours. So maintaining that work-life balance is really important, but really hard when you love what you do. And the culture of those individual companies can be very important. I will say small business is often very supportive of positive work-life balance, which is, one of the reasons I love working here where I do.
Okay, if there are no more questions, or we kind of give another hand to Jen for showing up today. A round of applause, or whatever way you like to emote over Zoom. And just thank you for being here. And if Peter has any other closing remarks, he can go ahead as well. But it's a great presentation, so thank you.
Yeah, well, it's that so grateful for Jen speaking to us today. I think all of you would know that who can you talk to when you look for expert. So I think it's a wonderful opportunity for all students at UCLA and working on SMART. So yeah, we definitely look forward to further collaboration with Jen's project. Yeah, thank you.
Thank you very much for the invitation. This has been the highlight of my day. So I really appreciate all the great questions.